Step 9, customizing the marketing mix. For this step, we'll be reusing the bi-clustering solution we obtained in section 5.4.1 using the Australian vacation activities dataset. So this code here just regenerates that solution by loading package bclust, loading the dataset and running the algorithm. This takes quite some time, so we have already done this. And we've looked at the solution and we decided we want to focus on segment 3. So what we need now is to extract segment membership from the bi-clustering solution and obtain the information which of our respondents are assigned to cluster 3 or segment 3 and which are not assigned to segment 3. And then we can use that information to characterize segment 3 and compare segment 3 to the general population. We're doing this using first function bi-cluster number and applied to the bi-cluster object returned, and this gives us the information on what do the clusters look like. Remember, in bi-clustering we're clustering at the same time rows and columns, so a cluster contains the rows that are assigned to a cluster and the columns which are assigned to that cluster. So BCN is a list. In this solution we have a 12 cluster solution, so BCN is a list of length 12, and each list element contains the information which rows are in this which rows of the original data set also active is in that cluster and which columns are in this cluster. And we can use this information to now generate the segment memberships. This we want to store in the vector CL12. And we initialize that vector as containing all missing values and having the number of elements equal to our number of respondents, which corresponds to the number of rows in our dataset. Now we are filling this by running through the list BCN. Sec-along BCN means we're looking at all list elements, so K will take values from 1 to 12. And then we will select the kth cluster, look which rows, which respondents are in that cluster, and assign the CL12, our cluster assignment vector, in these positions will assign the value K. So this generates now a vector which contains the values 1 to 12, but remember that bi-clustering doesn't assign every respondent, every row to a cluster, but some rows might not be assigned to any. So that's why if we tabulate that cluster assignment vector, we use exclude equals null, which ensures that missing values are not dropped, but they'll be included in this frequency table. And if we look at the results, we can see how big each of the 12 clusters is, but we can also see how many of the respondents were assigned to no cluster. And what we want to create now is a vector which contains the information of which respondents are in cluster 3 and which respondents are not in cluster 3. And we're doing this by looking at vector CL12. We say if it's not an A and takes the value 3, then this is true, and this means it's in segment 3. Otherwise this is false, and this means it's not segment 3. So we are creating here a binary variable which takes the value not in segment 3 and segment 3.